Hey everyone, welcome back to another exciting lesson in math. I mean, you should be so excited to be here today. And I know some of you are like, I don't want to, but come on, man, math is amazing. You just got to buy into it. That's all there is to it. You just got to buy into it. You got to be convinced. Anyways, today's lesson is our fifth in Unit 2, and we are going to be talking about different forms of quadratic functions. So far, you know the vertex form, and you know how to graph a parabola based on that form. You know how to identify the vertex. You know how to identify the slope pattern, whether the function opens up or opens down. You know how to describe that verbally. So we are now going to transition into other forms. Specifically for today, we're going to focus on what's called standard form. So your objective, I can convert a quadratic function to standard form. So if I give you vertex form, you should be able to make it look like standard form. We'll talk about what that means in a little while. But the point is these different forms allow us to see different things about the parabola. So like the vertex form allows us to see exactly what it says. It allows us to see the vertex. It allows us to see the slope pattern and whether the function opens up or opens down. Standard form is going to allow us to see the y-intercept really well, and it's standard form. So that just implies that it's the normal way of seeing a quadratic function. So first of all, remember, the vertex form shows the vertex, obviously. It shows whether the function opens up or opens down, and it shows the slope pattern, okay? And it is y equals a times x minus h squared plus k. And if you remember that the h and the k are your vertex, and then the a tells us opening up, opening down, and the modified slope pattern. Then we have standard form. Standard form is y equals ax squared plus bx plus c. And we actually talked about standard form of polynomials in the first unit. So when we were talking about multiplying polynomials, adding, subtracting, all of that, this is where that will come in handy, okay? So ax squared plus bx plus c. And what does it show? Well, it shows our y-intercept. And it will also show whether the function opens up, or the parabola opens up and opens down, and it will also show the slope pattern. Why is that? Because you can see that the a here is the same as the a here, okay? So this shows the opening up, opening down, slope pattern, same thing for this a value. They are the same value, okay? And then the last form is called factored form, and we're really not going to do a lot with factored form until later. But factored form looks like this: y equals p times qx minus m times rx minus n. You go, that looks really complicated. It's not. It's just I had to use variables that were different than the variables that I used in vertex form and standard form, okay? But what does the factored form show? It's going to show us our x-intercepts. It's going to show us whether the function opens up or opens down. But the key thing is x-intercepts there. So each one of these things show us different things. This shows us our vertex, a specific point. This shows us where the parabola crosses the y-axis. This shows us where the parabola crosses the x-axis. So you can see the value in each of those forms. All right, with that said, we're just going to do some converting from vertex form and factored form into standard form. So just some practice with analytical thought. Okay, whoops, go back there. So A is an example that we should go through, and we are trying to convert that function into standard form. So we got h of x equals -2 times x minus 1 squared plus 5. And my camera is extremely blurry. There we go. All right, so we want to convert that to standard form. Actually, before we do this, just as a side note so that we remember what these things mean, remember the vertex in this case is going to be +1, +5, because we change the sign here, keep the sign there. And then we know that it opens down because the negative a value. And then we know the slope pattern is going to be multiplied by a factor of 2. But let's now go into converting into standard form. So basically, we have to keep in mind our order of operations. And remember our order of operations: parentheses, exponents, multiply and divide, Add and subtract, right? Please excuse my dear Aunt Sally. Okay. Well, what does that mean for us here? Well, we got to do parentheses first. Remember, parentheses, the word parentheses here in the order of operations means, is there anything inside the parenthesis that needs to be done? Well, we can't because x minus 1 can't be combined. So we just have to leave it like that. There is no parenthesis operation in this problem, okay? I know some students might say, well, don't you distribute the negative 2 in? Well, that's not a parenthesis operation. That's a multiplication operation because we're multiplying the negative 2 times x and the negative 1. So no, we don't want to do that yet. We want to go on to our next thing. There is no parentheses. So we're going to go to the next thing. We're going to go to exponents. Well, do we have exponents? Yes, we do. So we have to address that. Well, what is an exponent? What does an exponent mean? Well, a square means that you're multiplying that term by itself. We're multiplying the parentheses by itself. So we're going to go ahead and rewrite this as negative 2 times x minus 1 times x minus 1 and then plus 5. So in a sense, that deals with the parentheses, okay? Or sorry, deals with the exponents. We got rid of the exponents. But let's just keep going with that idea. Let's multiply these out. X minus 1 times x minus 1 is x minus 1 squared. So let's simplify this. We're going to say x times x minus 1 minus 1 times x minus 1. And so that's what that means. We're going to distribute there. So we end up with x squared minus 1x minus 1x plus 1. And then combine like terms. So we have x squared minus 2x plus 1. So what did we do there? All we did was we squared the x minus 1. This is x minus 1 squared. So you'll notice I still have this negative 2 out front and this positive 5 at the end that I have not dealt with. So I'm going to put brackets around all of this, and I'm going to rewrite the negative 2 and the 5 in each of these so that I can see and so I don't forget it. Okay? So h of x, that is h of x. So now we have dealt with the exponents properly. We multiplied the x minus 1 squared, and we got this. If you want to do that as scratch work off to the side, that's fine. I still would need to see your work, but then you just take what you get and plug it into the function. Then we move on to multiplication and division. Well, which one do I do first? Do I do multiplication or division? I do whichever one comes first from left to right. In this case, there is no division, so I don't have to worry about that. In multiplication, I do have multiplication because I have this negative 2 out front. So I want to distribute that negative 2 into all three terms here. So we end up with negative 2x squared plus 4x minus 2, and then we have this plus 5 in the end. There's nothing to really combine from that distribution, so we dealt with multiplication and division. The next step is addition and subtraction, which in this case just means combine your like terms. So we only have negative 2 and the 5 as like terms, so we're going to combine those. But remember, we want to write this in standard form, and standard form meant that you are writing the highest exponent first. So squared is the highest exponent, so we're going to carry that down, negative 2x squared. Then the next highest exponent is the 4x, and then negative 2 plus 5 is positive 3. So that is my standard form of my parabola. This was my vertex form. This is my standard form. And that's all we're doing today is converting from one form into standard form. Okay. Let me make sure I got that right. And if you like the color better, you can go ahead and look at the slide to the left there. But you can see that essentially it's the same answer. Okay. For part B, it is asking, again, to put it in standard form, but you'll notice that this is not vertex form. This is factored form. So we're going to approach this a little bit differently than we would with the vertex form. But the process ultimately is going to lead to the same thing. Thinking of our order of operations, do we have any parentheses? Well, we have parentheses. Is there anything inside the parentheses that must be done? No, because I can't combine the x minus 5. I can't combine the 2x plus 4. The next step is exponents. Well, I don't have any exponents, so I don't have to worry about that. The next step is multiplication and division. And I do have multiplication. In fact, I have two things of multiplication. I have -3 times x minus 5, and then I have x minus 5 times 2x plus 4. So that causes us to ask the question, which multiplication should I do first? Well, in this case, it doesn't matter. And I'll show this off to the side so you can see it. If I were to ask you what 2 times 3 times 4 is, you would figure out, well, 2 times 3 is 6. 6 times 4 is 24. If we rearranged the order and said, well, what about 4 times 2 times 3? Would you get the same answer? Yeah, you would. 4 times 2 is 8, times 3 is 24. We get the same answer because multiplication is what's called commutative. You can multiply any set of numbers in any order and you'll get the same answer. So the same thing goes here. What do I multiply first? It doesn't matter because it's all multiplication. I could multiply the -3 times the first parenthesis if I wanted to. I could multiply the -3 times the second parenthesis if I wanted to. Or I can multiply the x minus 5 and the 2x plus 4 if I wanted to as a first step. Okay? I'm going to go ahead and do it from left to right because that's the standard way of doing it. So we'll multiply the -3 into the first parenthesis. So when I do that, I end up with -3x plus 15. Okay, so now I multiplied that, and I have to take that result and multiply it by 2x plus 4. Since I'm multiplying this whole result, I want to put parentheses around that. And then how do we multiply binomials? Well, we expand it. We say -3x times 2x plus 4, and then plus 15 times 2x plus 4. And then we could distribute. So we end up with f of x equals -6x squared minus 12x, distributing that. And then the 15, we distribute that in. We get plus 30x. Whoops, if I could write. Let me fix that with my whiteout. Cover that up here. So we end up with 30x. Uh-oh, that didn't work out very well. 30x plus 60. 30x plus 60. And then we'll go ahead and combine like terms. So we can see that we have the -12x and the 30x there. Writing it in standard form, we have f of x equals -6x squared plus 18x plus 60. And that is our standard form. Okay. And let me check my work to make sure I'm right. You'll notice in the work that's on the PowerPoint, I actually multiplied the x minus 5 and the 2x plus 4 first. You can see I expanded all that out. And I dealt with the -3 after I multiplied those binomials. So I distribute the -3 and then combine like terms there. But ultimately, it's the same answer. So it didn't matter which order I did it in, whichever way basically you feel more comfortable. Okay. So that is our 2 examples. Those should be on the right-hand side of your notes. And with that said, let's go ahead and go over 2 practice problems that you should do before you watch me do it. So go ahead and pause the video and come up with your answers, and then you can compare your answers to mine. For number 1, we are given g of x equals 4 times 4x minus 3 times 4x plus 9. Okay, and we want to multiply that out. That's in factored form. So I'm going to do it a little bit different than the way I did it before. Here, I distributed the -3 in. And if you want to do that, if you distributed the 4 in first, that's fine. You don't want to distribute the 4 to all of these terms, only the first parenthesis. But I'm going to go ahead and multiply these binomials first. So I'm going to write out 4x times 4x plus 9 minus 3 times 4x plus 9. And we're going to multiply those 2 out first. Distribute, you end up with 16x squared plus 36x minus 12x minus 27. And then we can combine those like terms. We got 16x squared plus 24x minus 27. Now we might be tempted to say, oh, we're done, but we're not because we left that 4 up here in the dust. We don't want to leave that in the dust, so we want to carry that down. 4 times all of this. 4 times all of this. And then 4 times all of this. We're just carrying it down because we haven't dealt with it yet. And then from here, we can distribute that 4 now. So we end up with, let's see, 4 times 16, that is going to be 64x squared plus 96x minus 108. And that is our standard form for converting our standard form from the factored form. Okay. All right, for number 2, it gave us vertex form. So it says y equals 3 times x plus 4 squared minus 1. Okay, I really want you to hone in on the standard form right now, converting vertex form to standard form. We'll deal with more factored form later on, factored forms later on, but right now our main focus is from vertex form to standard form. So you remember we got to deal with the exponents first, so we're going to expand that out. We get x plus 4 times x plus 4, and then we'll multiply that out. That becomes x times x plus 4 plus 4 times x plus 4. And then we distribute there. We get x squared plus 4x plus 4x plus 16. And then we can combine like terms. So we get x squared plus 8x plus 16. But remember, we still have this 3 out front and this negative 1 at the end. So we want to carry that down throughout the entire problem. We don't want to forget about it. And then we end up with distributing that 3 now. We get 3x squared plus 24x plus 48 minus 1. And then we combine like terms. So we end up with 3x squared plus 24x plus 47. Okay. So you can see that the numbers can get pretty big depending on what you're talking about. But that is an example or practice problem dealing with converting vertex form to standard form. And that, ladies and gentlemen, is the end of our lesson. If you have any questions, please comment below or seek me out in a tutoring session or ask me in some meeting somewhere. But hopefully you got a good understanding of just the different forms and how to convert from vertex form to standard form specifically. I will talk to you later.